I want to go through some significant figure calculations with you today, so to hopefully help you understand why the rules are what they are. In place of you're just memorizing rules, I want you to understand why they work the way that they do. Addition and subtraction rules are different than multiplication and division. Your addition and subtraction rules work like this. Let's say that I have two measurements that I want to add together to get a total measurement. Okay, so I'm going to just go ahead and add them together just like I normally would. Okay. Now, if you recall our significant figures, when we were talking about measurements, we said that the last digit that you record is always the one that has some error in it, has some estimation in it, has some uncertainty in it. So, in this first number up here, the 6.23 centimeters, the 3 is uncertain. It's the one that you estimated, the one that you had to guess on just a little bit. In the 12.7 centimeters, the 7 is the one that has some uncertainty in it. So therefore, when I add these numbers together, any digit that had uncertainty in it will carry that uncertainty through into the answer. So in my answer, because this is uncertain, this digit is uncertain. Because the 7 was uncertain, that makes this digit uncertain as well. So in my final answer, I'm only allowed to have one digit that has any uncertainty in it. So the final answer for this problem is going to be 18.9 centimeters. So to the proper number of significant figures, I have to chop my number off. I can't include this one because both of these had some uncertainty in them. So another way to think about it is if this is the digit that had uncertainty in it, you can chop all of the numbers off to the same place, and then that's where the final answer is going to be. Now generally you don't want to start chopping anything off until you actually added it together, because sometimes you're going to have to round, and you guys should have learned how to round a long time ago. So if this number is 5 or greater, you're going to have to round it up. So you don't want to ignore that digit when you're doing the calculation, but when you get to the end, you want to make sure that you only have one digit that has any uncertainty in it. So that's the rule that applies for addition and subtraction. For multiplication and division, I'm going to go through a multiplication example for you, but it will apply the same way to division. So let's say that I'm trying to find the area of something. So I have 10.3 centimeters times 0.21 centimeters. Now multiplication is different, so I'm going to go ahead through and I'm going to multiply this just like I always would. Okay, I have 3 decimal places here, so I'll have 3 decimal places down here. Okay, now, again, just like over here, this 3 has uncertainty in it because of the way we measured, because of the precision of our measuring instrument. This 1 also has uncertainty in it. So therefore, anything that I multiply those two numbers by is going to have uncertainty in it. So since I multiply everything up top here by this 1 times 3, 1 times 0, 1 times 1, all of these digits have uncertainty in them. Okay? Then anything that this got multiplied by is also going to have uncertainty in it. So when I take the 2 times the 3, that 6 is going to have uncertainty in it as well. So when I get down at the bottom, this digit, and this digit all have uncertainty in them. Okay? So I'm only allowed to have one uncertain figure in my answer. So I have to say, well, this is going to be the only one I'm allowed to use. Now in this particular case, I had a 6 over here, so that's going to make this round up. So my final answer is going to be 2.2 square centimeters, because it's centimeters times centimeters. So multiplication and division is actually a little easier to remember the rule for, because here I had 3 significant figures in this measurement, and I had 2 significant figures in this measurement. And so the number in the answer always matches the number of significant figures that was in the number in the least that you had in the numbers that you're multiplying together. So since this had 2, the answer is also only going to have 2. Okay? With addition and subtraction, you have to chop it off to however many decimal places it was.